Hello, everyone, and welcome back. Today, we're going to start a two-lecture look into the architecture of Le Corbusier. We're going to start out with the early part of his career today, and then in the next lecture, we'll take a look at late Le Corbusier. And by late Le Corbusier, I mean after World War II. Um, when we take a look at what he did early in his career, we're going to see that in many ways his work had some visual qualities that were common to works of other architects that we can label under the category international modernism. But when we really take a look at what Le Corbusier thought, said, and did, we're going to see that he had some really distinctive ideas that place him in a very different category for early modern architecture. So even though he's often considered one of the great designers of the heroic period of modernism, we're going to see that his ideas were slightly different. And I always like to start out our look at Le Corbusier with a little bit of class discussion about this image in particular. If we were meeting in person, I would ask the students to put this into a category, put this particular building into a category. And it usually doesn't take long before somebody says arts and crafts. And I say, good. Now, why do you think it's arts and crafts? And there are a number of reasons why this fits into that category well. We can certainly see what the basic materials are. Few, if any, of those materials seem to be mass produced or coming out of a factory, with the possible exception of the plate glass and the wrought iron railings. There seems to be an attention to a craft tradition here. We can see how the building is put together, how it supports itself structurally, and the detail that we see on the building seems to show some sort of craftsmanship, specifically with the stucco work. We can see the hand of the craftsman in the molding of the stucco and also in the painting of the stucco. So it's an interesting discussion. It's a little bit of a review of exactly what arts and crafts consists of. But most students are a little bit surprised to learn that this is actually one of the earliest buildings that Le Corbusier designed. This isn't at all what they expect coming from Le Corbusier's drawing table. But this is, again, one of the earliest buildings that he designed. It dates to the first decade of the 20th century. And yet 20 years later, we're going to see Le Corbusier designing buildings like this. This is Le Corbusier's contribution to the housing exhibit, which was organized outside Stuttgart in the late 1920s. You may recognize the aerial view in the upper left of the screen. This is the Wiesenhof Siedlung estate. This was a housing exhibit organized and promoted by the Deutsche Werkbund. And Mies van der Rohe was responsible for the overall planning of the site as well as for the apartment complex, which you can see in the upper left of the site in that aerial view. One of Le Corbusier's buildings is down to the lower part of the site, sort of the lower right, and perhaps you can sort of find the image of the building, which we have down here in the lower right in that aerial view up there. The building that Le Corbusier designed here was a duplex, and it has many of the qualities that we would associate with international modernism. Volume, not mass; regularity, not symmetry; no historical details. So it fits the categorization that Johnson and Hitchcock came up with for international modernist buildings. Beyond that, it seems to be based on some very basic geometric volumes, and it has sort of a white material that we're not exactly sure what it is. Is it stucco? Is it, it doesn't really discuss the the expression of material that we might find with stone or with brick or with wood construction, but it's this sort of anonymous white material and sheet glass that we see in so many international modernist buildings. So the question becomes, where did Le Corbusier start? How did he arrive at this international modernist duplex? And what were his thoughts along the way? We're going to see that Le Corbusier was not only a very thoughtful designer, but he also penned the architectural treatise that in many ways became the starting off point for a lot of discussion about modernist architecture in the early 20th century. So he's an architect, he's a theorist, he ended up doing urban design for some of his projects. He lived to be quite an old man, and he was practicing architecture pretty much up until the day he died. And so we're going to see a great degree of development over the years in Le Corbusier's architecture. The name that he coined for himself, Le Corbusier, was not his given name. His given name was Charles-Édouard Jeanneret. He was from the Francophone part of Switzerland, but in order to come up with a moniker for himself, he drew upon a family name and sort of selected that for himself. And we're going to see a couple of different points in today's lecture, at any rate, where Le Corbusier coins a term that is understandable if you know French, but is a little odd. It's not the normal term. It seems like he was trying to concoct his own vocabulary for his sort of modern design. And so let's back up. Let's take a look at where Le Corbusier started and see his development up until his contributions in the forms of international modernism. As I mentioned, Le Corbusier was born in the Francophone part of Switzerland. His family had long been involved in technical trades and in engraving, and it seems that that was the trajectory for Le Corbusier when he was a young man. He went to a technical trade school, but he became interested in the arts, and so he enrolled in the local art school and began producing drawings, watercolors. But the director of the art school was very highly influenced by English arts and crafts ideas. And so it wasn't long before Le Corbusier began adopting some of those ideas and taking his own studies of natural plants and some of the fauna around his hometown in Switzerland, and began developing patterns with them, patterns that then could be used in the decorative arts. We can imagine these patterns in the upper left showing up in wallpaper or perhaps in fabrics. And when we take a look at his design for the residence that we looked at earlier, we can see the development of pattern executed in stucco work on the facade of this building. Knowing that this is a building in Switzerland, all of a sudden the Swiss chalet type becomes apparent when we look at it. And we can understand that Le Corbusier was drawing from the local vernacular for some of the decisions for this design. So not surprisingly, it has very steeply pitched roofs, deep overhangs, like we might expect in a damp climate or a climate where there's a lot of snow. You need to get the snow off the building and away from the building if possible to avoid any problems due to the weight and the moisture of the snow. Hence the very steeply pitched roofs. The building is raised up off the ground plane. The basement of the building, sort of a semi-interred basement there, is going to protect the living quarters of the house up on the second and third floors from the rising damp or from the cold that comes in the soil. And so we can see this as Le Corbusier's drawing from the vernacular tradition and developing upon it, like we might expect for an architect interested in arts and crafts. But this is just going to be the start, because Le Corbusier understands that arts and crafts, with its basis in the local vernacular, is only going to provide an understanding of what local architecture should be. And Le Corbusier is going to be interested in casting a wider net, in looking further than just the particular locale, and trying to figure out what should architecture be in the 20th century. So young Le Corbusier is going to travel. And here in this map, we can see a number of different trips that he took. And throughout them, we're going to see him studying architectural history. We're going to see him studying the way that architecture can create urban form. But out of all these trips, it seems to be the trip through the Balkans and in the Mediterranean areas that had the most profound effect on him. He was certainly taking a look at historical architecture, some of the great monuments, and we can see him paying attention not only to the overall form of the buildings, but also the details of the building, trying to understand how geometry and texture and color were all coming together to create the effects in the detail. We see him taking a look at the way that architecture creates urban form. In these two examples here, we can see him doing something very interesting, traveling through Germany, buying postcards of a particular city, and then on the back of the postcard, making analytical sketches and taking notes about the way that the architectural form is creating urban space. But again, it appears to be the interaction with classical monuments around the Mediterranean that had such a profound effect upon him. In his own recounting and in his own biographical statements, he mentioned that while he was up on the Acropolis at the Parthenon, he had some experience that was unlike any other experience that he had had. It was almost a mystical experience. And the way that that architectural monument should elicit that response from him switched a trigger. And he ended up paying particular attention to the classical tradition, trying to unlock what it was in the classical tradition that had such a profound effect on him and on others. And certainly the geometry that we can see in classical buildings was one thing that he understood as a basis of classical design. And so in his analytical sketch in the upper center part of this screen, where we can see sort of a representation of the city of Rome with the Castel Sant'Angelo, with the Colosseum, with the Tiber River, we can see the way that he's finding basic three-dimensional geometric volumes within these monuments. So as he's traveling around, as he understands that the classical tradition has some great lessons to teach architects, it's not surprising that his own architectural production is going to turn in a classical direction. Another early building that we can see, this time from the 19-teens, around the area that he's from. This is actually over the border in France, but it's very close to his hometown in Switzerland. In the design of this villa and the way that the villa sits on the site, we're going to see that Le Corbusier was drawing lessons from classical design. One of the basic points of departure for classical design is identifying a precedent. Taking a look at a great example of whatever building type you have responsibility for. Take a look at that historical example and draw lessons from it. I believe that in the design of the Villa Favre-Jacot, Le Corbusier had drawn inspiration from the Villa Madama, which is outside the city of Rome. If we take a look at the image to the left of the screen here, we're going to see a hypothetical reconstruction of what the full design of the Villa Madama would have been. This plan in this view, and also the other plan that we see next to it, are organized with north to the top of the screen. And so it's organized in a north-south direction. And the villa complex was designed to be built into a terrace that is carved in a hillside or carved out of a hillside that is located to the north of the city of Rome, where the descent of the hill, which is to the east, or in this large plan to the right, the descent of the hill goes down to the Tiber Valley. And so if we take a look at this hypothetical reconstruction, we can imagine a north-south terrace that has been cut into the hillside. We can imagine the gardens and the building block itself and the courtyard in front of the building block sitting on that terrace. And there are going to be some parts of the complex that overlook the Tiber Valley, which is to the right of the plan. But at the same time, there are going to be some parts of this complex that are actually built into the hillside. Most notably, if we take a look at the circular courtyard that is right at the center of that plan, and if we go to the left, we can see something that is quite clearly theater space. That was intended to be carved into the hillside, and the structural support for the seating would be foundations actually laid in the hillside. The villa was designed for the Medici cardinals as sort of a suburban getaway for the cardinals while they lived in Rome. And really less than half of that complex was actually completed. If we take a look at the plan on the upper right of this screen, we see the part of the building that actually exists today. And if you do a comparison and contrast between what exists today and the hypothetical reconstruction, you can see that it's roughly half of the building itself that was constructed. And then down in the lower part, we're looking from a lower elevation up to the villa, again, carved into a terrace in the hillside, and then the hill that rises above it. And so as it exists today, we don't have the elaborate sequence of entry from south to north that we see in the hypothetical reconstruction. Rather, you enter directly into what was intended to be a fully circular courtyard, in this case, a half-circular courtyard or a semicircular courtyard. And from there, you get into the building block. Beyond that, there is this garden that's laid out with a cross shape in the garden. And everything opens, all the views open to the right of that plan. From the building block itself, there are these windows that overlook the Tiber Valley. From the garden terrace, again, something that is laid out with that rectangular cross shape in paths around the planting, you look out over this lower level pond and out, or this lower level reflecting pool, and out over the Tiber Valley. There are some parallels between how you approach the Villa Madama, seen on the left, and how you approach the Villa Favre-Jacot, seen on the right. In both cases, you approach to a semicircular courtyard, and then on a central axis, you've got the main entrance into the building. And in both cases, once you enter into the building block, you turn 90 degrees for views out over the countryside, right? Things descend and the topography descends, and you can look out over the countryside. In the Villa Madama, which we're seeing in the plan oriented to correspond to that view of the villa right there, you're looking out over the Tiber Valley. If we take a look at the Villa Favre-Jacot, and here we see an axonometric, and the plan is oriented to correspond to that, you would enter into the building, and then all of the views out are to the left. You could go into a whole series of spaces and either look out through windows and a colonnade that looks out over the countryside, or you could actually walk out of the building onto a terrace and overlook the countryside. And so there's a basic correspondence in the planning between the Villa Madama and the Villa Favre-Jacot. And not surprisingly, if we take a look at the planning of the villa and if we take a look at the details, we're going to see some other qualities of the classical tradition that Le Corbusier is drawing upon for this particular building. If we take a look at the plan, if we can identify where the entrance is, we can see that there is a central axis from that front door, and that the main social spaces in the building are lined up along that central axis. And at least in the primary spaces and along that sequence, they're symmetrical about the axis. Right? And so we enter into a small vestibule. And then there is a transitional space with staircases on either side that rises up to the upper level so that from upper circulation you can look down. And looking up from the ground floor, you can see that circular shape, which is so very clearly expressed in the parapet wall and also in the ceiling there. And then you enter into some social spaces all along that central axis. And those primary social spaces beyond it in themselves are symmetrical about the central axis. The secondary spaces, obviously, taking a look at the plan, diverge from a strict symmetry. But at least the initial sequence of spaces is symmetrical. If we come in and take a look at the details on the exterior of the Villa Favre-Jacot, we're going to see that there are some elements there that appear to be Le Corbusier's reinterpretation of the classical orders. The pilasters at the corner of the buildings seem to be reduced and stylized Corinthian columns. The small columns that we see framing the windows appear to be reduced in detail reinterpretations of the composite order. And so doing what architects did in the 19-teens, 1920s with a sort of reinterpreted and strict classicism, using some of the basic classical principles and very strongly expressing some of the geometry, at least in the entry sequence in the Villa Favre-Jacot. So obviously, Le Corbusier was paying attention to classical architecture. Obviously, he was drawing lessons from it. But he's not going to end his exploration of architecture there. It's going to be an important starting point, but he's going to continue and grow and develop. And we're going to see where he goes with this in the treatise that he published in 1923. The treatise was written in French, published in 1923. Eventually, it was translated into English, and the English translation for the title is often towards a new architecture. That's a little bit of a misnomer. A strict translation from the French would be towards an architecture. Not towards a new architecture, but towards an architecture, which is kind of interesting. Corbusier didn't think that he was necessarily identifying the way forward for a new architecture. He thought that he was tapping into some of the basic ideas of architecture, period. Not just new, but architecture, period. In the treatise, we're going to see that there are a number of pages with illustrations, and those illustrations contrast images much like what we have here. There are a few pages in the treatise where we can see an illustration of an ancient Greek temple contrasted with a contemporary automobile. This was a highly provocative thing for Le Corbusier to do. The ancient Greek temple had long been considered sort of the epitome of human achievement in architecture, and also the starting off point for the entire classical tradition. So here we've got this revered architectural example, and he's putting it on the same page with what at the time was modern technology and mass production. How on earth can you reconcile these two divergent things and look at them as something that you can compare and contrast? What's the point behind that? Well, I'm going to read a little bit of the English translation of Le Corbusier's treatise, and we'll try to dissect what it was that he was doing here. In the treatise, Le Corbusier wrote, "It is necessary to press on towards the establishment of standards in order to face the problem of perfection. The Parthenon is a product of selection applied to an established standard. Already for a century, the Greek temple had been standardized in all its parts. When once a standard is established, competition comes at once and violently into play. It is a fight. In order to win, you must do better than your rival in every minute point, in the run of the whole thing, and in all the details. Thus we get the study of minute points pushed to its limits, progress. A standard is necessary for order in human effort. It involves a search for a perfection and a harmony beyond the mere practical side, a manifestation not only of perfection and harmony, but of beauty. Here we have the birth of style, that is to say, the attainment, universally recognized, of a state of perfection universally felt. The establishment of a standard is developed by organizing rational elements following a line of direction equally rational. The form and appearance are in no way preconceived. They are a result. What exactly did Le Corbusier mean, and how can we understand what it was that he was doing here? Well, it's very clear by putting these illustrations with that text that he believed that both the ancient Greek temple and the contemporary automobile were examples of what he was talking about. In other words, both of these have standards, and there's a process of selection that results from the establishment of those standards. Yet, it's very clear that the ancient Greek temple and the automobile don't share the same standards. They've got different standards. But within each category, they've got their own criteria. So to start with, Le Corbusier is assuming a division into different groupings. And that division, understanding his attention to ancient classical architecture and the classical tradition in general, those categories would refer back to the type. Now, in class discussion before this, I've talked about plan types, the centralized type, the theater type, the longitudinal church type, the palace type, for example. That typological organization is the architectural use of the philosophical method of finding the type. And this comes from ancient Greek philosophy. Okay, so in the classical tradition, there's this idea that anything that we can see in the world is a physical manifestation of some non-physical ideal type. And here we have a quick definition of type. The non-material essence, consisting of all necessary qualities for a class of thing, and those qualities are known through studying examples. So let's have a little exercise here. Let's try to understand what is the non-material essence, what are the necessary qualities for a class of thing, and just for our exercise, let's identify seat, something that you sit on, a seat, as a class of thing. What are the necessary qualities for a seat? Well, we sit on a horizontal surface. Is that valid if the type of example that we're looking at is a bar stool? Yes, bar stools have more or less horizontal surfaces that you sit on. Is it valid for a sofa? Yes, a sofa has a horizontal surface that you sit on. What about a stool? Yeah, a stool, three-legged stool, yeah, that has a horizontal surface. Good. That's one quality for the type seat. What about a backrest? Does a bar stool have a backrest? Well, maybe, it could. Does a sofa have a backrest? Yes. Does a stool have a backrest? No. And so all of a sudden the backrest is not a necessary quality for seat because not all examples have it. Upholstery. The sofa has upholstery. The bar stool doesn't necessarily have upholstery. The three-legged stool doesn't necessarily have upholstery. So upholstery isn't necessary. What about a structural support, something that is going to raise the horizontal seating surface up above the ground level? Does a sofa have structural support for the horizontal surface? Yes. Does a bar stool? Yes. Does a stool? Yes. And so through this study of examples, and by eliminating what is not common to all examples, we end up understanding that for the type seat, the necessary qualities consist of structural supports and horizontal surface that you sit on, and that's it. That same method of reducing down to the necessary qualities would arrive at the non-material essence that is the type. And everything within that category is nothing more than a physical example and an imperfect example of the type. And so Le Corbusier starts with a typological study and organizing things into categories, each of which is going to have its own set of criteria. What do you do then? Once you identify these different types, where do you go with it? Well, you develop the type rationally. For the ancient Greek temple, there were some criteria that were put into practice here. The criteria all focused on visual perfection. Okay? Those were the standards for the ancient Greek temple. If we take a look at the diagrams on the left, we're going to see a number of different diagrams that show what was sought, the optical illusions that would result if it was built exactly as sought, and then the deformations to each part of the ancient Greek temple that were required in order to achieve the visual perfection. Okay, if we take a look at E, we see the perfection that was sought. A completely flat base or stylobate, columns that are equidistant and perfectly vertical. Right? But if we take a look at F, we see the optical illusions that would result if we built the Greek temple with a perfectly flat stylobate, and if we had perfectly vertical columns equidistant one from the next. They figured out that there were these optical illusions that would occur to E if we built it exactly like that. And so through trial and error, through discovery, through figuring it out, they ended up with G, where the stylobate or base is not perfectly flat. Rather, it rises towards the center, both on the short end as well as on the long end. The columns themselves are not perfectly vertical. They angle in ever so slightly, and the further away that you get from the center, they angle in increasingly. The columns themselves, they realized that if they had perfect cylinders for the columns, that through optical illusion, you would have diagram H. It would appear that the column shafts were concave. And so as a result, to counteract that, they added what's called entasis to the columns, which we see in D. In D, the widest part of the column is about a third of the way up the column shaft. And above that, it tapers ever so slightly to where the column shaft ends and it meets the capital. And then below that third point, it either descends cylindrically or it descends and angles in ever so slightly. But the result of this is that that optical illusion of having a concave column is overcome by the entasis. So establishing the standard of visual perfection for the temple, selection comes into play. Selection of exactly what you do with the stylobate, exactly what you do with the columns. There were a whole variety of other types that you would develop rationally. Le Corbusier was always interested in the steamship, the steamliner, right? And the way that engineering would provide the criteria for developing that type rationally. He was interested in other works of engineering, such as grain silos, and the way that engineering and the function of the grain silo would inspire or lead to some decisions and how that was designed and built. What about for architecture? Well, Le Corbusier didn't have particularly good things to say about the contemporary state of architecture. He wrote, and here I'm going to continue with the translation of his treatise. He wrote, "Architecture is one of the most urgent needs of man, for the house has always been the indispensable and first tool that he forged for himself. But men live in old houses, and they have not yet thought of building houses adapted to themselves. The lair has been dear to their hearts since all time, to such a degree and so strongly that they have established the cult of the home. Architects work in styles or discuss questions of structure in and out of season. Their clients, the public, still thinks in terms of conventional appearance and reason on the foundations of an insufficient education. Our external world has been enormously transformed in its outward appearance and in the use made of it by reason of the machine. We have gained a new perspective and a new social life, but we have not yet adapted architecture to it. Our engineers, on the other hand, produce architecture, for they employ a mathematical calculation which derives from natural law, and their works give us the feeling of harmony. The engineer, therefore, has his own aesthetic, for he must, in making his calculations, qualify some of the terms of his question, and it is here that taste intervenes." Le Corbusier also wrote, "There is such novelty in the forms and rhythms produced by the construction methods, such novelty in their ordinance and in the new industrial, rental, and urban programs, that we finally understand in a flash the true and profound laws of architecture, based on volume, rhythm, and proportion. The styles no longer exist. The styles are outside of us. If they still assail us, it is as parasites." So Le Corbusier is going to advocate a rational development upon the type, but for architecture, that includes the consideration of volume, rhythm, and proportion. These are some of the basic qualities of architecture for Le Corbusier: volume, rhythm, and proportion. And then finally, Le Corbusier is going to advocate the search for universally valid results. Back in one of the quotes that I gave just a few minutes ago, he said, "Here we have the birth of style, that is the attainment, universally recognized, of a state of perfection universally felt." That universality assumes that we're all hardwired to understand and appreciate things. And that too is a classical goal for architectural design and for composition in general, the universality. Arts and crafts designers didn't think that their designs necessarily would appeal universally across the world to everyone. Classical designers did. They thought that their designs would appeal to everybody because we're hardwired to appreciate a central axis, symmetry about the axis, tripartite design. And so this focus on universally recognized, universally felt perfection is also a classical quality that Le Corbusier is bringing into his treatise. As sort of a correspondent to what he wrote about here, we can take a look at paintings that he produced during the 1920s at the same time. And these paintings depicted what he believed were the objet type, or the object type, a specific item that has been refined and perfected over the years such that it is a very close approximation of the ideal type. Now again, the type from classical philosophy is non-material, it's the essence, right? But some examples of the type are going to be closer to the type, are going to be more faithful to it, because there's nothing extraneous, because it's just a more perfect example of what it is. And in everyday household objects, he saw a great variety of different things that he believed were very close to attaining perfection, or as perfect as we can in the physical world. The guitar, for example, the form and what the guitar is intended to do correspond very closely, and we've got a beautiful form that results not because somebody thought, oh, this would be a great look, but because the form functions well. If we take a look at the wine bottle, for example, we're going to see a number of design decisions in the wine bottle that function well for containing wine and for preserving wine. Wine is somewhat it's something that needs to be conserved. In the wrong environment, in too much sunlight exposed to the air, not at the right temperature, it can degrade and turn to vinegar pretty quickly. So given the materials that are available, what would the perfect container for wine be? Well, glass is non-permeable, non-air permeable, and so glass seemed over the years to be a good material with which to create a container for wine. What should that glass container look like? Well, you want it to be big enough so that you can have about 5 to 7 generous glasses of wine, right? Just enough for 2 or 3 people to have a couple of glasses each, and enough for you to have in 1 or 2 sittings, right? How would you close the bottle of wine to make sure that no air gets in to ruin the wine and to turn it to vinegar? Well, one of the materials that they had at the time was cork, the spongy bark of an oak tree that grows around the Mediterranean. And cork is great if the cork is integral, but you have to really jam it into a small opening in order to make sure that there's an airtight seal there. So obviously the top of the bottle of wine isn't going to be very large. You don't have an open mouth. Rather, you have a rather narrow mouth so that the cork is more likely to stop the air from getting in. So you have a neck and you have a rather narrow mouth to the wine bottle. At the bottom of the wine bottle, you have an indentation so that any sediment that's in the wine is going to fall down to the bottom and collect in a ring around the bottom of the bottle of wine. And so it doesn't easily get mixed up with the wine when you pour it. All of these things were developed over time and resulted in what Le Corbusier considered to be an objet type, a physical object that was extremely close to a perfect exemplar of the type. He's aiming at universally valid results, and that universality, again, is a classical goal. So what we see Le Corbusier doing here is pulling some principles from classical philosophy, classical design, and bringing them together with a rational development. And so his ideas are very interesting because they do bring together aspects of classicism and aspects of rationalism. And one example that we can take a look at of a building that dates to about this time, and that must be a good example of that design process that he talked about in his treatise, was the Citron House. And to be honest with you, the Citron House is not a particular example. Rather, it's a house type that he promoted that could be built in a variety of different locations. There was some variety that Le Corbusier allowed for in the Citron House. In some climates, it might make sense to place the Citron House right on the ground level. In other climates, it might be important to raise the living floors up above the ground level. We can imagine particularly damp or cold climates. Maybe you want to raise the ground floor above that. And so there was some variation. In sunny climates, maybe you want to have some sort of sunshade in front of a large glass window in order to protect the interior from the heat of the day. So there was some variety here. But basically what he's talking about is a house type that is going to be structurally supported by 2 parallel walls of masonry. And if we take a look at the plans in the image to the right of the screen, you can see those thick poche walls that are parallel and on opposite sides of the building. He thought that ideally these would be built in a modern material like poured-in-place concrete, but he didn't demand that. Different locations are going to have different materials available. Maybe you build this out of brick, maybe you build this out of stone. The material didn't matter so much. It's the way that you define the space and structurally support it. And then within this space, we're going to see a very interesting section. And again, if we take a look at these diagrams in the illustration to the right, you might see the diagram labeled coupe, which is actually section through the building. Le Corbusier put to the left of that section some of the functional spaces or private spaces, such as a kitchen, such as bedrooms, such as bathrooms. But then to the right, you can see there's a double height space. Le Corbusier felt that the living room of the house required more volume, not just an adequate floor area, but a taller ceiling, because that's what human beings need in their spaces. And so there's this understanding about not just a basic functional resolution, but rather also taking into considerations people's response to issues of space and form. And so Le Corbusier came up with a very interesting section here for the building, and that was part of the type. There were a few examples of the Citroën house that were built in France, in southern Germany, and also in North Africa. But he really saw this not as a particular project, but rather a house type that would be valid no matter where you built it. Let's take a look at the name here, Citroën. Interesting name. And again, we can see Le Corbusier coming up with vocabulary. For those of you who are car buffs, you may be familiar with a classic French automobile manufacturer, Citroën. And what Le Corbusier is doing here is definitely a riff off of that name. And so, again, drawing the parallel between architecture and modern technology, automobile technology, sort of saying that this is as technologically advanced and as engineered to perfection as some of the contemporary cars. And if we take a look at his illustration of the Citroën house down below, or a digital creation of what that interior space would look like up above, we see the volume that he felt was important for human habitation. But again, Le Corbusier is not going to stop here. Soon after this, he's going to come up with a set of prescriptions for architecture that he identified as the 5 points of architecture. And let's go through this point by point. Point number one, raised on pilotis. Pilotis is in quotation marks here because the vocabulary is not typical French. What we understand is that he meant piers, but he called them pilotis, again, coming up with phrases, coming up with names for things. He believed that the building ought to be raised up above the ground plane on piers. This was possible because of modern materials, modern technology, but it was also going to preserve the ground plane for circulation. Le Corbusier was planning for a modern world in which we needed to live more densely packed in order to preserve farmland for food production. And so if we're living tightly packed one to the other with modern technology for transportation, it's going to be important to keep the ground plane open for transportation. And so the living space should be raised up off the ground plane on pilotis. He's establishing a point load system of piers for the building. On the second floor of the building, the first living floor of the building, with a point load system and with the possibility of a little bit of a cantilever of the floor level beyond the last piers, we have the possibility of having an open plan. There are no load-bearing walls that are going to define interior space. We can have our different functional areas open one to the other completely. We can put up partition walls. We can have movable screens. We can do whatever we want because the point load system and the floor plan allow for a great degree of flexibility. So we have an open plan. We can define the interior spaces as wanted, as needed, They can be as large as we need, as small as we want. They can take on any geometric configuration because they're not determined by load-bearing walls. Number 3, free facade. If there is a little bit of a cantilever of the floor level beyond the last structural piers, then that means that the facade of the building on the outside edge of the floor is not going to have to accommodate vertical structural supports because of that cantilever. Therefore, the design of the facade can respond to a variety of criteria, but they don't need to show where the structure is because they're independent of the structure. Ribbon windows. In a house, on the exterior facades, we use windows to look out, but not many of us lay on the floor to look out the window. Not many of us stand on chairs to look out the window, rather sitting or standing. And so he's going to advocate windows that are above table height and a little above, up to the height that's a little above head height. And he's going to advocate organizing them horizontally. And that is going to set up a horizontal organization to the windows, a ribbon window on the facade. And then finally, roof garden. If we're packed together in more densely organized cities, we still need outdoor space. The outdoor space is going to be on the roof. Modern technology in construction makes that possible. Modern technology, modern materials means that we can have flat roofs without leaking. Now, here he's a little bit optimistic, right? A flat roof is very rarely a good idea, but nevertheless, he had faith in modern technology and modern materials, and he thought that it would be possible to have a waterproof flat roof, which we could then inhabit. That would be our outdoor space. So when we take a look at the 5 points of architecture, which again, he advocated or he put together after the publication of his treatise and after his design of the Citron House, the 5 points of architecture, in a way, are how to develop the architectural type rationally per the modern context, based on the modern world in which we live, based on the need for density, based on the opportunities provided by modern materials. How do you develop any architectural type rationally? Well, these 5 points of architecture. And of course, the great example of the 5 points of architecture is going to be the Villa Savoye. This is a weekend getaway for a wealthy family from Paris. And as a result, we're going to see a number of decisions here that involve chauffeurs and cars and servants. But there's going to be this focus on the life of the family, the life of the wealthy people who come to live here. Just taking a look at this one exterior view, we can see a couple of those 5 points. Raised on pilotis and then ribbon windows. In this case, the ribbon windows have glass in some parts and in other parts are open to a roof terrace, which is the roof garden, only on the second floor here that Le Corbusier was talking about. If we take a look at the aerial axon in the lower part of the screen, if we take a look at it carefully, you might see the driveway that approaches the Villa Savoye, and you might see a little view of a car that's about to disappear under the Villa Savoye. This tells us something about the ground floor of the building. There was this drive that would approach the Villa Savoye, and in this aerial view, you would approach on the upper drive. Your chauffeur would come around and circle around the interior space under the overhang there and drop you off and then continue on, well, it's the 1920s, he's a chauffeur, would continue on his way. And so we get the sense that the ground floor of the building is used for circulation here, specifically automobile circulation. If we take a look at the ground floor plan, and here the approach is going to be in the upper left of the plan, we can see the point load system of the pilotis. Right? You can imagine how the car approaches from the upper left. There's a turning radius that is accommodated in the geometry of the enclosed ground floor here. The chauffeur would stop sort of at the bottom of that turnaround and let people out. And then he would continue, and you can see where the cars would be parked in the ground floor here. So the ground floor accommodates transportation. We can also see some of the rooms for the servants here. The chauffeur is in the upper right. In the plan, we've got a few different rooms for maids, which are in the upper left. If we were to enter the building at the ground floor here, we would enter into a space where we would see two different ways of ascending and descending in the building. In the one view to the left, we can see the start of a ramp, which rises very slowly through the space. But then in the right, we can see this staircase that is much more contained, much more cramped, and that would permit quicker ascent through the building and also a descent down into the basement. What we see here are two different circulation paths for the two different sets of people who are going to be in the house. The ramp is going to be for the wealthy family that use the house. The staircase to the left is going to be for the servants. Now, to our eyes, this may be pretty odd. I don't know how many of us grew up in houses with servants. I certainly didn't. But in some of the larger, older houses that we can take a look at, even houses designed up to this point in time, often there were completely separate circulation patterns for the family and for the servants within these large houses. As an example, we can take a look at this house, which is in Winston-Salem, North Carolina, a house designed for a wealthy family in the 1920s that had servants. Today, it is a sort of a catering and rental center, which can be used for a whole variety of different events, including weddings, as you can see here. But let's take a look at where the circulation is here in the building. If we take a look at the elevation of the building, and if we can see that gable that faces us and find the entry, the main entry, which is sort of to the lower right of that gabled extension in the elevation. If we come down to the plan, we can see where the front door is. We can see this rather cramped little foyer there. But then it opens into a hall. And in the hall to the right, there is the living room. Below the hall, there's a sitting room. To the left, there's a dining room, right? And then beyond that, beyond the dining room, we can see a more narrow wing of the house. And those are the servants' quarters, okay? Let's take a look at the vertical circulation. In the hall, back close to the front door, we can see the staircase that is broad, that is on display, that is somewhat elegant, that is well lit, and the bride in the image to the left is ascending on that staircase. But if we go back to the servants' quarters, a part of the house that is completely separated from the rest of the house by walls and doorways, you can see a second staircase there, something that is much smaller, it's more cramped, it's out of view. That was the vertical ascent that the servants were supposed to take. And so even in the United States in the 1920s, there were houses that were still being designed with separate circulation for the family and for the servants. And so at the Villa Savoy, we see something that was typical for families of this socioeconomic status, but what's different is that they're being put on display. And we see this low, slow, leisurely ascent for the family. And then we see this business-like ascent and descent as quick as you can to get where you need to go for the servants. Up on the main floor of the house, we begin to see more of the 5 points of architecture. Much of the main floor here is going to be a roof garden, right? And we can see it through the floor-to-ceiling plate glass windows from the living room out to the roof terrace. But if we take a look at the other walls of the living room, which are down below, we're going to see the way that he organized the ribbon windows. Again, above table height and extending vertically to just above head height, but organized horizontally so that the plate glass windows, the operable windows, that are put on the house and that are organized on the facade are going to be ribbon windows. At least on the front and the back of the house, there is that cantilever beyond the last structural pier. If we take a look at the plan of the house down at the bottom of the plan, you might be able to see where the point load system of the structural piers are, and you can see that there is a distance between those piers and the outside edge of the floor. So a little bit of a distance there, and that allows the facade to be a free facade, completely independent of the vertical structural supports. Roof garden, again, connected to the living room. And there was also a portion of the roof garden that was on the third floor of the house. Again, for the family, right? You can see the ramp that gives that low leisurely ascent up there. And it's somewhat enclosed because he felt that this was going to be a place where they might want to sunbathe. And so they might want some privacy. And so he encloses an upper area with this wall. So the house overall is a great example of the 5 points of architecture. And even though we know that Le Corbusier had a very particular set of ideas about modern design from his treatise, this building can quite easily be categorized as an example of international modernism. Volume not mass, regularity not symmetry, no historical detail. And so it can be put together in a category alongside what Gropius was doing at the time, alongside what Mies was doing at the same time, 1920s, 1930s, even though we know that there were some pretty different ideas between these three different designers. When we take a look at the design of this building and other buildings that Le Corbusier designed at the time, yes, he was looking to develop the type rationally, but there were some things that he was paying attention to. In this view, in these diagrams of another villa that he designed in the 1920s, we get a sense of his attention to geometry and proportion. Again, proportion, volume, rhythm were things that he felt were basic architectural criteria. And here in these diagrams of this particular villa, we can see the way that he's paying attention to the width to height proportion, in some cases drawing upon some classical proportioning systems. And we also get a sense of the rhythm that he's trying to develop here. It's pretty clear that there were also some details that he was sort of imitating, or in some of the details, he was imitating other things that he was paying attention to. And if we take a look specifically at his choice of materials for the handrail and the way that it comes together with some of the elements seen on the roof of the building, it's pretty clear that he was fetishizing the steamer, right? Those large ocean steamliners of the time. And he was also paying attention. There was, for as much as this might seem to be a rational, cold thing, there was some sensual quality for the building. In the master suite, he included this spa-like setting for the bathtub, and included this sort of built-in chaise next to it, so that if you just got out of your hot bath, maybe you want to sort of languish a little bit on the chaise. Paying attention to color and people's reaction to color. Le Corbusier also designed furniture. And in the lower illustrations here, we can see a chaise that he designed, which is actually quite comfortable. If you ever get the chance to sit in one, give it a shot. It's very comfortable. And interestingly, he allows the chaise to have a variety of different angles to it. You can either sit up or you can sort of lay down in it. The chrome curved part of the chaise is sitting on horizontal bars that are covered in ribbed rubber. And so you can pick up the seat and that chrome frame, and you can rotate it for a more upright seat or for a more sort of laying down seat. And once you set it back down onto the frame, those rubberized bars are going to prohibit it from shifting. And so it's very comfortable, and it allows you to sort of to adjust based on what you want to do. If you want to take a nap, if you want to sit up and read. He also designed a line of furniture that we see in the illustrations to the lower right, which are quite obviously based on some basic geometry. If you ever sat in the chairs, you'd find that, in my estimation, they're just not all that comfortable. You're either sitting there with your elbows digging into your ribs, or you're sitting there with your forearms up on the upper part, and it's almost like you're in flight. You're kind of hanging there, right? There, your forearms are going to be at shoulder height, if not a little above, and it's just not a very comfortable way to sit. And the guy who posted the image all the way to the far right about one of these Le Corbusier chairs, he posted it on a blog, and his caption was, "Not even Emma is comfortable in a Le Corbusier chair." So there is a sensual quality to what Le Corbusier is doing here. But what we've seen in this brief look at his early career is a very interesting trajectory over roughly a 30-year period, where he starts with some initial lessons in arts and crafts, moves into a fascination with the classical tradition, theoretically finds a way to integrate some basic classical notions, type, universality, into a rational development, and then shows us how to do it with the Citroën house, with the 5 points of architecture, and with the Villa Savoye. This is going to provide a very strong theoretical point of departure for modern design, as well as a very interesting set of examples for other modernist architects to look at. And when we come back and take a look at what Le Corbusier did after World War II, we're going to see that his development continued throughout his architectural career.